knowledge about limit function. So, yeah, we already know that there are 5 laws to limit. So if you work for limit, you can consider these 5 types of law. Sum law, the limit of sum is the sum of limit. So, like previously we learned about logarithmic function, limit also has similar laws. So, for example, first, sum law. The limit of a sum is the sum of the limit. Limit sum equal to limit function x fx n plus limit function gx. So you need to understand this characteristic of law. If you face this kind of equation for limit function, so we can consider first law to solve the equation, the question. Why we use limit? Why we use limit? Because sometimes we face any equation that has not exactly for the value. For example, the solution is near any kind of exact value. Near 2, near 3, near 4, but not exactly 2 for the solution. Not exactly 3 for the solution. So we can consider limit to process the case or the problem. Okay, first law, we use additional law for solving the equation. Second, we have different law. We consider subtract as operation for the equation. The limit of a difference is the difference of the limit. So if your function in the limit considers subtract operation, you can use subtract to solve the limit equation. So you can use this second of law. Limit fx subtract with gx equal to limit fx negative limit gx. Easy, right? Okay? And then we go through third law, constant multiple law. If we have constant number in your equation or your function, we consider third law to solve the problem. The limit of a constant times a function is the constant times the limit of the function. If we have this kind of equation, we consider the third rule, third law. Limit c or constant multiple with function fx equal to c multiple with limit fx. Understand? You just remember the nature of this kind of law. Okay, and then number 4, product law. The limit of a product is the product of the limit. If we have multiplication operation between two equations in the limit, so it equal with limit first function or equation multiple with second, and then the last one is quotient law. The limit of quotient is the quotient of the limit provided that the limit of the denominator is not 0. So you need to make sure if you have this kind of quotation, so you need to make sure the denominator is not equal to 0. So you can use the 6th law. Oh, sorry, 5 law. So here you need to make sure this denominator not equal to 0. Yeah, you're right. Understand? Yeah. We go to this example. Use the limit law and the graph of function f and function g in figure 1 to evaluate the following limits if they exist. So here we have 3 kinds of limit equation. First one, A, limit fx plus 5gx. Second, limit fx multiple with gx. And the last one, limit fx divided by gx. So you can see from this graph. Okay. So we need to solve like this one. Graph of f and g. If we limit negative to fx equal to 1 and limit negative to gx equal to negative 1, so if we have this one, so we can consider law on first law. Limit fx plus, so we can divide or separate the function inside limit, because we can assume the function in the limit can divide into 2 kinds of function, which one is fx and the second one is gx. So we can consider first law of limit, and then second, by third law we can consider if there are multiplying function inside limit, multiplication function inside limit, we can consider third law. So we can put 5 outside the limit. So if we have 1 and negative 1, limit function fx is 1 and limit gx is negative 1 plus negative 5 multiplied with negative 1. Easy, right? Okay. If we see for the second question, we see that limit x to 1, fx equal to 2, but limit x to 1, gx does not exist because the left and right limits are different. So we cannot use law 4 for the desired limit, but we can use law 4 for the one set limit. So like this one, we need to define fx and gx. Fx equal to 2 and gx equal to negative for the first question, and then second is equal to so limit this one does not exist because these two not equal. These two kind of result not equal. So that's why we define limit x to 1 and gx does not exist, because from these two the result is not equal. So if the result is equal, we can define this is exists, but for this proving the result value is different, left and right is different, negative 4 and negative 2 is different. So we assume or conclude that the left and right limit are equal, not equal. So the third equation, example 1c. If limit x to 2 fx equal to 1.4 and limit x to 2 gx equal to 0, because limit of the denominator is 0, we can use 5 law. Because for 5 law, we need to make sure our assumption the denominator not equal to 0. Yeah. So how we solve this one? This is not exist. Okay. Understand how we can use these 5 kind of law to solve the problem. So next, if we use product law repeatedly with gx equal to fx, we obtain following law. So we have power law for 6 law in this limit. For if you have repeated function inside limit, so x1, x plus 1, x plus 1, x plus 1, so it's mean x plus 1 power by 3. Yes, this one. This means it means if you have limit fx power by 3, so you can assume that the result from limit fx is power by 3. With n is positive integer. And then for applying this 6 limit law, we need to use 2 special limit. X to a, limit c equal to c, and x to a, x equal to a. So these limits are obvious from an intuitive point of view. The words of draw graph y is equal to c and y is equal to x. And then if we put fx equal to x in law 6 and use law 8, we got another usable special limit. So if limit x power by n equal to a power by n, if you have limit x to a, x power by n equal to a power by n. How is this? Limit x to a, x power by root square n, so this equal to a power by root square. So we can consider this kind of law. Okay. How if there is a polynomial or rational function and a is at the domain of x? So you can just direct substitution property which continues a, like this one. Fx equal gx x not equal a, so limit x to a, fx limit gx x to a. Yeah, I think it is better if you go through the exercise. Okay. Yeah, you can work on this exercise. We have 11 questions, so please work on it and submit when we will conduct next meeting?
Thursday.
Thursday we have holiday.
Oh yeah.
Oh, you can just submit the result
Oh, okay.
on my locker.
Okay, Pak.
In my locker, you just put it and take a picture.
When?
Thursday.
Okay.
Okay. In Thursday, you can submit on in my locker. Or do you need more time? It's okay if you need more time because you will have a lot of to do. You will have a lot of deadline for your assignment and the exercise, so you can extend the submission deadline. It's okay. Finally, if you finish, you can tell me.
Okay.
Okay. Any question? If not, yeah, you can do this exercise and submit it later. Okay. I think that's all for today. Thank you. Any question? No? Okay. Yeah. Okay. You can continue your work. Okay.